In this video, we will give a short description of OpsMx product and a demonstration. Every company in the world needs to deliver software faster. And they're unable to do that because software delivery itself has a lot of manual steps. Our dream and vision of OpsMx is to help all these companies deliver software without any human intervention. Essentially, eliminate all the manual human steps involved in the delivery of the software. This is a long-term dream. Let me tell you why software delivery breaks at scale and speed. So fundamentally, there are two frictions. There's an orchestration friction, which we call, and then there's an intelligence friction. Orchestration friction deals with how do you automate the workflows. Typically, a company like Cisco will have 15,000 of these workflows scripts. And then how do you do multi-cloud deployments and rollbacks? A group like Cisco would do 400,000 deployments a year. Now, this is the problem that Spinnaker, etc. address. Now, there's an intelligence problem, which is essentially with every step of the way, there's a gatekeeper that sort of approves the releases, etc. There are some steps wherein risk assessment, an SRE or a QA engineer looks at logs and metrics and test data to figure out if this is good to go to the next stage or not. And then you don't want somebody to push code and go all the way to production. You need fine-grained policy checks that need to be there. And even if it goes into production, you need to be, if there's a problem, you need to be able to sort of trace back to where the issue has started. So all these problems we call the intelligence problems. Now, as the delivery speed increases or the scale increases, these frictions become big problems. Now, the way OpsMx solves this problem is through a system of intelligence for software delivery. It's got two layers. It's got the intelligence layer we call the autopilot, which is essentially a data layer. Then there's an orchestration layer, which is this open source Spinnaker, for which we are major contributors of. So roughly, this looks like the automated workflows, continuous deployments. On top, we have the intelligence layer. Now, this system of intelligence is designed to work with other CI and CD platforms, not just Spinnaker. It works with Jenkins, Kubernetes, Argo CD, potentially Azure DevOps, Puppet, etc. Diving deeper, essentially, if you look at our workflow here, there are human steps. And the goal of autopilot is to automate these human steps through gates, either fully automated or semi-automated gates. You can have some of them or all of them as gates. And these gates, once inserted either into your Jenkins pipeline or Spinnaker, etc., you collect the data, do based on the stage, you do machine learning, etc. You could have a policy gate, you could have an approval gate, etc. And this works with any CI/CD platform. So in the short term, people will use a couple of gates. Over time, they'll use more gates, and our long-term vision is it'll get an interconnected gate. That's what the long-term vision is, and ultimately an intelligence process you can define. On the orchestration layer, Spinnaker is a large open source community. OpsMx is a major contributor to Spinnaker, and we have an enterprise Spinnaker. And now let's begin the product demonstration.
All right, great. Well, first off, I want to thank everyone for joining us today. I want to bring you through a quick slide to set the stage for what we're going to show you today. During the demo, I'm going to start with talking a little bit about the orchestration problem and how we solve some of the key problems here around orchestration. One piece is going to be talking about automated workflows and sort of how those are created and how those scale. The other piece is going to be about, we'll talk a little bit about the multi-target nature of the underlying orchestration layer. That being, being able to deploy to Kubernetes, being able to deploy to the more traditional cloud services like EC2, and we'll show you an example of that. And then the third piece around orchestration that we want to talk about is visibility. As deployments are happening, you want to be able to see what's deployed and where it's deployed, along with interacting with those deployments to do things like rollbacks or scale ups. And so we'll talk a little bit about that. And then we'll move into the intelligence layer. And for the intelligence layer, I want to talk a little bit about, the gatekeeper and the gates that exist at those stages, and how we're doing data consolidation to ultimately allow for a faster approval process for that gatekeeper. Then we'll transition a little bit into the app risk and verification along with diagnostics. Gopi and I will talk to you a little bit about how we can create a gate around this automated verification, and then ultimately how we can use this tool to ultimately diagnose issues that were uncovered while the tests were running or while the Canary deploy was running. And then I want to talk a little bit about policy and security checks, another area where it takes a tremendous amount of time to ensure that you're complying with policy, and how we can help in an automated fashion compress the time that it takes to get there. So with that said, let me go ahead and jump right in. We always start off with our application dashboard. This is our window into the status of deployment. So an SRE or a DevOps manager or an engineer, a software engineer can come and ultimately see the status of the various deployments that are happening. And here, the way we've organized the structure is, obviously there's the top level, which is the application, and then the services that lie beneath that. Now, we're going to kick it off with orchestration. So let me go over to the orchestration layer here real quick and start with, talking a little bit about automated workflows. Here, what we're seeing is that pipeline that's associated with that SpecDrive application. And if we were to take a closer look at this particular workflow, we can see the code that is sort of moving through a process. It's starting off with a QA build, which we're reaching back out to Jenkins and ultimately kicking off that build, and then ultimately deploying to QA. So we're deploying this someplace so that the new code is actually up and running. And then we're running our QA verification process and then going through that QA approval process. Now, again, these types of pipelines are very, very simple to create. And ultimately, you're able to come in here as a customer and ultimately start to create these pipelines. And ultimately, the other piece of this that's important to note here, and I think one of the things that some of our larger customers really embrace, is that ability to do two things. One is to create pipeline templates. So one of the challenges that you have as a large organization is, how do you scale usage of this tool, and how do you bring new applications on quickly? We've solved that problem here with this orchestration layer, in that we allow you to create pipeline templates. Those templates are going to represent some of the best practices that you want to enforce as part of your automated workflow process, but it gives your teams a place to start from. They're not starting from scratch each and every time. They're ultimately using the pipeline template to then modify that template to then go ahead and actually onboard the application that they're looking to onboard as part of the automated workflow process here. Now, the other piece that allows for scale, especially when you start talking about larger numbers of groups and larger numbers of developers that are looking to onboard applications, is our support for pipelines as code. So if you were to look at, our ability to go ahead and actually, export a pipeline as a JSON file, take that, check that into Git, And now the developers and the DevOps folks that are actually building out these pipelines can work in an environment that they're comfortable and familiar with, and ultimately, go through the process of making those modifications to a template, checking that in, or cloning that repository, making the modifications, and then checking that in, and ultimately having that get pushed up to Spinnaker as that orchestration layer. So again, the idea behind this is that these automated workflows are simple to set up, and ultimately allow you to go ahead and map out the process that you want the code to travel down, and ultimately give you the ability to go ahead and actually quickly replicate that process as you want to bring new applications online. So that's sort of the automated workflow piece. The other piece that I want to talk about is around the multi-target nature of the product. So obviously one of the things that we are helping our customers do is really sort of bridge that gap. Some of them are on the journey toward microservices. Others, are sort of, still deploying monolithic applications, via EC2 or GCP. And the nice part about the orchestration layer here is we give you that ability to go ahead and actually bridge those gaps. So here you can see here I'm set up to deploy via Kubernetes, and that means any Kubernetes cluster. That Kubernetes cluster could be running on-prem. That Kubernetes cluster could be running on GKE. It could be running on Azure. It doesn't matter to us. Through our agent-based technology, we're able to go ahead and actually deploy something into that cluster and ultimately make that cluster now a target for Spinnaker. The same exists for the more traditional cloud resources. In this case here, I've wired up my AWS account. And so now I can make AWS a target and EC2 a target for my deployment. So that would include things like, building my software, baking an image for that software, and then ultimately deploying that image to AWS. And then making it available to my customers. And so again, that ability to go ahead and actually add multiple deployment targets to that layer solves a really large problem for customers who are in all various states of their journey in terms of CD and sort of how they're deploying software. This gives us that flexibility to accommodate a large, and a wide swath of customers who are looking to go ahead and do those types of deployments. The other piece that I wanted to cover, as we talked about, the orchestration layer here, is that visibility. If I were to take a look at, sort of what was deployed where, and ultimately, how do I get my arms around, what deployments and what versions of a deployment are, and where are they deployed? This really makes it easy to be able to do that. And so here, I can simply go ahead and actually choose their various accounts that are associated with this. And so if I want to look at what's in QA and staging, I can very easily filter on that and ultimately see sort of what's deployed, what versions of the software are deployed in QA, what versions are deployed in staging, and then simply clicking on that, adding production to that mix. So now I've got sort of a very filtered window and a very sort of narrow field of vision here, because I want to see exactly what's deployed where. The other piece of this is that I can now interact with these deployments. If I need to go ahead and actually do something like undo a rollout, let's say I've rolled something out, a problem has been reported, I can roll that back right from here. I can initiate scaling. So if I want to go ahead and actually scale this deployment, I can do it from here. Or I can initiate things like rolling restarts. And so again, that ability to not only just see what's deployed where, but interact with those things is all part of that orchestration layer that underlies the OES platform. And so I wanted to make sure we covered that and made sure that that piece of this was clearly understood. So with that said, I'm going to move back over, per our sort of, the overview here, move over to the intelligence layer. And let me start by talking to you a little bit about gatekeepers and the various types of decisions that those gatekeepers have to make. So for that, we'll move back over to our application dashboard. And here, we can see SpecDrive is an application that we're looking at here. And the approval gate that exists here to move from QA to staging. Now, what we're attempting to do here is, again, compress the time that it takes to ultimately give that person who has to make these decisions access to all the information that they need. And so here I can very clearly and easily see that I have access to the Git repositories, and I can see sort of what code has changed, and I can ultimately review that. I have access to the various Jenkins jobs that were associated with this. And so I can simply come in here, and if I want to review the console output of that Jenkins job, again, that information is right here and easy for me to access. The same thing with external systems that are part of my software deployment process. They may be change management systems like ServiceNow. It might be, sort of something like Jira, where I want to ultimately be able to go ahead and actually look at the status of those tickets, make sure that they're in order, make sure the appropriate approvals have been secured as part of these tickets. And again, making that very easy and simple to get to. And then we get into, some of the external tools that are in my tool chain here, external to CD, essentially. The Sonar Cubes of the world for things like static code analysis, or Twistlock, or Aquasec, where I'm doing those types of scans. And I want to ultimately make sure that I can understand what the results of those were. And again, we're bringing that information together. We're making it simple for that gatekeeper who ultimately is charged with making a decision as to whether or not they want to approve this and allow that person to ultimately have very quick access. Now, the other piece that we're doing here is we're ultimately creating a system of record. And so this here represents that system of record for this particular release and the data that was available to this gatekeeper at the time. And so ultimately, we're able to very easily, again, if we needed to roll back or ultimately do a post-mortem and understand sort of what data was available and when, it's all here. So that is, really the strategy here around helping compress the amount of time that it takes a gatekeeper to review the relevant information and ultimately understand whether or not they're in a position to approve or reject this particular build moving on to the next phase. Now, the next part that I want to talk about is the app risk verification and diagnostics. Here, really the name of the game is reducing the amount of time that it takes to do this type of analysis. And what we've done is, and this is really where Autopilot as a part of our stack shines, is giving you the ability to go ahead and actually wire up all of your log and metric collection information so that we're able to collect this data. Now, what we're doing with this is as you're running, a test suite against software, or you're running a canary deploy, we're ultimately gathering this information and ultimately comparing what we've gathered or observed against a baseline. And so ultimately, what the net result of this is, you're only ultimately ending up with looking at the information that's really relevant. We don't have to worry about parsing through. In this case here, I believe we were talking about 7,500 lines of logs that we were able to collect during this particular test process. We are now isolating and giving you a field of vision that is really just the log clusters, the 4 log clusters that potentially would have an impact on this build. Now we're parsing those things and ultimately using things like natural language processing to understand those log messages and ultimately categorizing them. But as these things come under review, we also give the customer the option of recategorizing these things. So in the event that they disagree with sort of what we've categorized, they can certainly ultimately recategorize these things, and the model will learn from that recategorization. They can also document the reasons for those reclassifications. The other thing that's important to note here is with each of these log clusters, we also give you the ability to tag that log cluster. So I can come in here and actually tag this. Now that I understand what it is, I can tag it. I can document why I've tagged it this way. And what's nice about this is that if this were to come up again in this context, these log messages were to be seen again in this context, we're no longer going to have to search for, sort of the root cause. We'll have tagged it and documented it here. And so that'll save me, from that piece moving forward. So I want to stop here real quick though, and I want to ask Gopi, real quick, if to give some insights on this as well. I know this is something that you and the team worked extremely hard on. Let me stop there and give you a chance to comment.
Sure, Bob. Thanks. Actually, this is one of the areas machine learning really shines, right? So when we're processing a very large content of log files, the classification of errors is hard. Particularly, accuracy is important in terms of false positives or worse, false negatives. And not only that, the efficiency in which we are able to process these tens of megabytes of log files is important. There are systems that try to imitate it using regular expressions and say, take the Elasticsearch rules, run some regular expressions to find these structures. But the problem with those approaches is that they have to be continuously updated. Or worse, they fail to identify the errors in the specific context. For example, the file not found is a serious error in some context, but in others, it can just be ignored. So by using the feedback mechanism in our system, you specify ignore this one in the specific context, and through that UI that Bob was showing, with that feedback will be taken in the context of the error occurring, and then that will be applied to the later ones. So here we are doing two things really well. One is the error classification and the context of the error in which it's occurring. And the second one is we are annotating and allowing collaboration between the teams. After this annotation is done, you share that information, the triage information, with the rest of the team members. And even a new user coming in, when he sees that error, the system tells what was the triage info and what was the resolution for it. For example, one of our customers, Juniper, they have hundreds of builds they run every day. In that, even if 3 to 5% of those builds fail, that still comes to like 50 builds a day, which 5 or 6 different engineers have to look at. So here, by simply showing the error context and giving the annotation, giving them triage information, already they save tremendously, and they only have to really look at 2 or 3 of those errors, and the rest they can get the information from the system. So automated analysis is one of the most common use cases we see in the market now.
Excellent. Thank you, Gopi. That was great. The other piece that I want to mention as we sort of move forward here is we don't stop at logs, right? Obviously, the other piece of this is we're allowing you to also collect the metrics that are associated with this. And, and again, looking at it from the same perspective, sort of what was expected versus what was observed. And as you can see here in this particular example, I have a baseline for the latency that's associated with this particular page load. And you can see there in blue what the expected or what the baseline looks like. And then I've got what was observed in this release. And obviously, we've observed significant changes in characteristics here. And so ultimately, again, as it relates to scoring, when we see something this far deviating from baseline, we're ultimately gonna fail this build, or ultimately bring the score down to a point where someone's going to need to take a look at it. Now, the other piece that's nice here is, obviously, as you're going through and looking at this, again, the idea behind this is to sort of narrow the field of vision you need to have in order to solve this problem, is that correlation piece. And so now that we've agreed that between the logs and the metrics that we have some form of issue, the diagnostics piece starts, and ultimately, again, looking for that correlation between what we were seeing in the logs and that anomalous metric behavior that we were seeing, to better understand and triangulate sort of where we should be focusing our attention when it comes to trying to ultimately diagnose where the problem is here. And so as Gopi had mentioned earlier, that level of collaboration and that ability to go ahead and actually now start the process of diagnosing this through this tool is another huge time saver for our larger customers who, again, if you think about running hundreds, if not thousands of builds, and then ultimately, being able to have this tool narrow that sort of what you need to be looking at in terms of understanding sort of where problems might be, it's a tremendous time saver. and something that ultimately is going to allow you to increase your velocity without introducing additional risk, because you're getting the information that you need for those problem deploys and only having to focus on those problem deploys without having to filter through that or looking for that proverbial needle in a haystack. So that's the if we were to go back to sort of our overview, the app risk and verification along with diagnostics. Let me now shift gears a little bit and talk about policy and security checks. And again, I think what we're looking at here is another gate that we want to make sure that we put the release through. Now, to talk a little bit about policy for a moment, typically what organizations are doing, and especially larger organizations, are putting high-level policies in place. They want to make sure that their pipelines are conforming to these high-level policies. As an example, and a very simple one, blackout windows, especially in retail and other sort of businesses where they don't want software deployed at certain periods of time. Or things like being able to control open ports and public-facing load balancers, those types of things where they want to ultimately go through and make sure that pipelines are conforming to, their security policies or their sort of business policies. And here, we allow you to go ahead and ultimately define those policies. Which, that by itself isn't really the true time saver. The true time saver here is when it comes time to sort of audit against those policies. We're saving you literally hours of work because you don't have to stream pipeline by pipeline looking for any exceptions that may exist in the policies that you've set forth. You've defined the policies here, and in an automated fashion, we're ultimately evaluating those pipelines against the policies that you've set, and ultimately ensuring that a pipeline isn't proceeding if there's a violation. And then ultimately giving you the opportunity to come back and triage that violation and ultimately understand it, work with the team to remedy that violation, and then run the pipeline again. Again, this is a tremendous time saver as it relates to not having to again, go pipeline by pipeline and run by run. Automating this process is the key, because again, it goes back to giving you the ability to increase velocity without increasing risk. And then I think the other piece that I wanted to talk about as part of this is, from a security perspective, is the audit trail. Now, obviously, when we talk about audit trails and auditing, we think about these things in the form of postmortems. If something has gone wrong and I want to go back and see what happened and when. But I would also suggest to you that it's just as important to be able to have access to this data for things like internal auditing. Meeting with an internal auditor and not having to spend days getting data together about what ran and when and what artifacts were deployed. The system of record here, the system of intelligence, provides you with that information. And then if you were to meet with an external auditor, again, the same thing. You're not going to spend days or weeks preparing for that meeting where you need to pull together all this information. It's here, it's available to you. And ultimately, from a security perspective, you can go back and review these things as well and make sure that, again, policies are being adhered to, and ultimately, all of the gates are passing, and then ultimately these things are running. You can also analyze the ones that don't run successfully and better understand why. And so ultimately, we want to make sure that you're able to, one, deploy your software in a safe manner. We want to make sure that you can increase the velocity of those deployments, and again, without introducing additional risk. And I think that's really, the tenets of sort of the overall intelligence layer here. So that's all I had to share for today. I don't know if there are any questions, but we can take it from there.